Synology NAS is usually the storage location of personal files or company data, and it is beneficial to be able to access this data permanently and from any location. Therefore, in this video, we will discuss the possibilities of Synology NAS to set up external access. When we use our NAS in our own network, we work with a local IP that is initially only accessible in this network. If we now want to access our data while on the move via PC or mobile devices, or to enable synchronization or backup to an external NAS, we need to connect the home NAS to the internet and make it accessible from the outside. In normal environments, only your router will receive an external IP address. There are several ways to reach our home network from outside. Depending on the situation, we can use our external IP address for this purpose, or services based on it, which allow simplified access from outside. Synology offers the following services: DDNS and QuickConnect, two simple, free, and secure services for external access. Before we take a look at the possibilities, let's take a quick look at the classic internet connections, since not every remote service works with every internet connection. Internet connections are usually provided over the older IPv4, but the newer Internet Protocol v6 is becoming more widespread. We will discuss the behavior of the protocols in detail. The well-known classic is the pure native IPv4 connection. Here our router receives an external IPv4 address of the internet provider through which we communicate or exchange data with the internet behind the router. This means that devices and services from outside cannot simply access the company network. This is only possible via port forwarding on the router, which must be configured, and here we distinguish between two variants. First, the variable IPv4. This is usually found on normal internet connections. This means that the external IPv4 address changes in certain rhythm, for example every 24 hours, and this poses the problem that we always need to know the new current IPv4 address to connect from the outside. Especially this last aspect makes external access difficult and is neither easy nor comfortable for the normal user. The second alternative is the fixed IPv4. In this case, our external address remains the same. So we can always use exactly this address to reach our network. However, a fixed IPv4 usually have to be booked separately with the internet provider and paid accordingly. In general, you should find out which options the respective providers offer. Since the 90s, it is already known that there are not enough IPv4 addresses available worldwide to supply the growing number of internet-enabled devices. Therefore, IPv6 standard was developed, which makes considerably more addresses available on the internet. The most important difference with the IPv6 connection is that an external internet IP is not only assigned to the router, but to each device connected to the internet has assigned its own IPv6 address. This also includes our NAS. It would be then accessible via the internet using the fixed IPv6 address, and no network address translation or port forwarding would be necessary. Also, our firewall would remain unchanged. The internet or internet connections currently use both described protocols, which are not compatible with each other. This is not a problem for pure surfing the internet, but it does present one or two hurdles for external access, especially since we have only worked with IPv4 in the past. With a single stack that is native internet connection, we get a public IPv4 or an IPv6 address, but there are also providers who offer us access via both protocols. This is called dual stack connection. If we always want to connect from one IPv4 port to another IPv4 port, or from one IPv6 port to another IPv6 port, we have no problem. Instead, it becomes problematic if we have an IPv6 connection at home, for example, but we are located in a hotel that has only one IPv4 address on the internet. Even a simple remote access to our NAS wouldn't work anymore. The same applies to Dual Stack Lite, DS Lite for short. Dual Stack Lite is virtually a mixture of IPv4 and IPv6. Here, IPv4 packets are tunneled into IPv6. So you don't have a public IPv4 address like on a native connection, but a private IPv4 that you can't reach from outside. This connection has become the standard for many internet providers in the last years and posed a problem for many customers because the usual external access suddenly stopped working. However, to ensure that every customer can now conveniently and securely use the NAS remotely from their internet connection, Synology provides two free services with QuickConnect and DDNS. Both services enable us to have a secure connection via SSL. They can be easily set up in DSM in all Synology NAS, and we only need a free Synology account and of course a working internet connection. Simply explained, both services are to be seen as intermediaries between the internet and our home network. With both, we can set up a so-called host name, so we don't have to remember the long external IPs. Both QuickConnect and DDNS connect us to our home network because you know which external IP addresses belong to our host name. And this includes IPv4 addresses that are not fixed and change more often. So we just have to remember the DDNS host name or the QuickConnect ID, and the respective Synology service connects us to the current external IP and thus to our disk station. Let's get to the most important properties and thus also the most important differences between these two methods. QuickConnect doesn't require any router configuration, while we need to forward ports for DDNS. Both connections are equally fast if we have open ports. If a direct connection is not possible, for example, because there are no open ports or the DS Lite issue is present, QuickConnect will connect via Synology Relay Service, while DDNS cannot connect in this scenario. QuickConnect first checks whether a connection via the local network is possible, so that inefficient routing via internet doesn't occur with local access. With QuickConnect, we do not have the option to use our own certificates, while with Synology DDNS, we have the option to use free Let's Encrypt certificates. In general, however, both services are inherently secure HTTPS connections. Before we decide on a service, we should also know the limitations. QuickConnect cannot work with all services or protocols. This is not important for all users, but you should inform yourself before. On this slide, we see which applications are supported by QuickConnect. Where do problems arise? Firstly, external access via file services such as FTP, SMB, AFP, NFS, or WebDAV is not possible. Alternatively, the file station would work for this. Secondly, an external backup via hyper backup to the device using QuickConnect is not possible. We would have to work with USB media or backup to the Synology C2. And third, connection to the NAS via VPN and the QuickConnect address is not possible. iSCSI targets are also not accessible via QuickConnect, but this is not really a limitation since iSCSI targets are usually addressed directly in the local network anyway due to the performance requirements in such environments, and the iSCSI address is used. With DDNS, we have the problem that no external connection can be established if a wrong IP stack is used or ports are not forwarded. Internally, problems occur if there is no NAT pass-through, which we cannot go into further in this context. What are the numerous advantages of the two solutions? QuickConnect supports, as said before, all connection types, doesn't require open ports, and is therefore ideal for beginners as well as DS Lite users. Also useful is the detection whether the user is located in the local network or externally, since access is then not established via the internet in the first place, and this is particularly suitable for those users who commute between the home network and external locations and access the data in the same way. DDNS, on the other hand, doesn't limit us in any way in accessing programs as long as we have all the necessary ports open. For a better understanding, let's have a look at the process and the setup of both services, and we want to start right away with QuickConnect. When we connect to the QuickConnect ID, more happens in the background than the user actually sees. First, the service checks whether it is located around the home network and can reach the NAS directly. If yes, then the direct local connection to the NAS is established. If no, check number 2 is performed, namely the WAN test. Here, QuickConnect checks if we can establish a direct connection to the external IP address. If yes, then the direct connection is also established here. If no, continue with step number 3, the so-called hole punching test. Here, QuickConnect searches for open ports or open a port to continue to establish a direct and therefore faster connection. If this attempt also fails, the connection will be established through Synology relay server instead of directly. This usually happens when we connect the NAS in a DS Lite and we have only one IPv4 internet address or have absolutely no ports open in the router to be used. Unfortunately, the relay server route is slower than a direct connection due to the technology, but for some users it is the only way due to limitations or settings of their internet connection. How do we set up QuickConnect? This is easily done via the control panel in the QuickConnect section. All we need is a free Synology account and set our requested ID here. After successful registration, we will also see this QuickConnect ID in the bottom section, which we can also enter into our Synology apps, and also the QuickConnect.to address that we need if we want to access our NAS from our browser. There is also the tab Advanced Settings. Here we can specify whether to allow connection through Synology relay server when direct connection is not possible. We can also give QuickConnect the option automatically open ports on our router if this is possible. This would of course have the advantage that we would have the chance of the fast direct connection if our router allows this. We can also prohibit or control access to certain functions via QuickConnect in the lower area. This would be useful if, for example, we wanted to give users access only to Drive but not to DSM or other services. Let's take a look at the properties and setup of DDNS. Unlike QuickConnect, DDNS is quite simple. Here the DDNS address always points to the public IP of our local home network. To make the NAS accessible from the outside, we set a share or port forwarding for the program ports in our router to the local NAS address in the so-called net firewall. The translation into net means network address translation and stands for the conversion of the external internet address to a local address. Port forwarding is the rule for the conversion to IP and port. If these are not correct, you cannot connect to the NAS via DDNS. The setup in the DSM is similarly simple as with QuickConnect. In the control panel, we go to External Access, click on Add, and can choose one of many DDNS providers. If we choose the Synology service, we will need a free Synology account here as well. We then look for any host name and select a domain from a drop-down menu. In our case, our DDNS is mysynology.synology.me. In the next window, we are asked if we want to create a Let's Encrypt certificate. This video is about easy access and we do not deal with the certificates, but a short info is appropriate. We don't need a new certificate to establish a simple, secure HTTPS connection because a standard certificate with the address synology.com is pre-installed. However, if you try to access the site via various browsers, you would get a warning here that an untrusted HTTPS connection should be accessed because the certificate address doesn't match. If this is not perceived as annoying, the desired access can still be confirmed. However, in order not to confuse users and create trustworthiness, a certificate matching the respective address is required. Here we offer the possibility to get this with little effort and free of charge via well-known provider Let's Encrypt with one click immediately when creating the DDNS address. In contrast to the QuickConnect, we must now set up port forwarding in the router. Basically, these settings are quite simple and identical on most devices. However, please refer to the manual on the respective manufacturer. We also recommend that you do these port releases manually for better control and security. Basically, we only specify which external incoming port is passed to a specific internal device. In the example, mysynology.synology.me 5000 goes to the local address that you can see here, 192.168.1.10.5000. So if we type mysynology.synology.me into a browser from the outside, our router will forward the incoming port 5000 to the internal port 5000 to the local IP of our disk station, giving us access. On our website or in the help articles, you can find all important ports needed for protocols or packets. If DDNS access should be possible, in principle, we can find out here which ports we have to release for the service to be used. QuickConnect is compatible with all internet connections and allows easy access to most of DSM's web services, which we can then access through the browser or Synology mobile apps. However, there are limitations in protocols and some DSM packages. For example, we couldn't realize WebDAV, rsync, or external backup to another NAS via hyper backup with QuickConnect. DDNS requires a suitable internet connection, and appropriate port forwarding. For example, if the NAS is located behind the DS Lite port, it would not be accessible via DDNS. However, DDNS offers almost no restrictions, so we can reach all common services or Synology packets from the outside. QuickConnect is therefore aimed at home users or small businesses, while DDNS is ideal for power or business users. For more information about DDNS and QuickConnect, please visit our homepage or read QuickConnect white paper.